Hi, my name is Pat Lehman. I work at Rochester Harley-Davidson. I've been here almost 4 years. I started directly after graduating college with an automotive engineering degree. And throughout college I took a special interest in engines, particularly race engines. I spent most of my time throughout college drag racing and building engines. I also did an internship with an engine builder one entire summer. And when I graduated, I came here. They had just got a dyno facility, which is inside of this room, Cycle Dyne, and they wanted to get into more performance engine stuff. So I kind of set up this small machine shop. This is a flow bench. This is where I measure airflow through cylinder heads. This is where I do all the cylinder head boarding and grinding. I do the machining on the mill. I cut the valve seats and mill cylinder heads and things like that on that machine. We also have a boring bar and honing cabinet and parts cleaner. Nothing too radical, but all the necessary things to build engines, to do machining like that. Everything is machined in this facility, and it's assembled in another building where we do the general service work and things like that. It's a lot cleaner atmosphere than over here. I'm going to try to keep this fairly short and make it knowledgeable. I kind of want to show you guys a few basic concepts and also show you kind of what I've applied in the cylinder head that's going on your motorcycle. I'll start out. This first formula here is how horsepower is calculated. It's the torque of the engine times the RPM divided by 5252. So if you look at a dyno plot of any engine, it is always going to cross at 5252, and the torque curve is a direct correlation to the airflow through the engine. At peak torque, that is where the most air is moving through the engine, and as it falls off, horsepower is also going to tail off. But if you want to make more horsepower, you've got to make more torque, and the way to do that is to move more airflow through the engine. So that's what I was trying to accomplish with the cylinder head porting, and that's always the goal with any engine. The next formula is compression ratio, and that is the swept volume of the piston. So the distance that the piston travels from the bottom of the cylinder to the top, plus the chamber volume, which is this volume here. It also includes the head gasket thickness, and if the piston is dished, you add that. If it's domed, you subtract that volume. So it's swept volume plus chamber volume divided by chamber volume. On this particular engine, it's 160 cc's. There's 2 cylinders, so it's 80 cc's per cylinder of swept volume. So if you took 80 cc's and you added a chamber volume, this one must be around 11 cc's, divided by 11, it equals out to 8. This equals 8.3 to 1 compression ratio. I didn't CC all of these components, but it's probably, I think the stock compression ratio of this engine is around 8.5 to 1, and we've done some milling to both the cylinders and the head, so it's probably going to be slightly higher than that. So that gives you kind of an idea of how compression ratio is derived, how horsepower is calculated, and how you increase torque on an engine. Next, I'm going to cover some of the basics of airflow through the cylinder head and some of the things I've applied to your guys' cylinder head. I'll start on the inlet side of the engine. Air comes into the carburetor, travels down the intake manifold and into the port, and it has to make its way around the valve. So one of the biggest restriction in the port is obviously always going to be the valve, because that is the cover over the hole. So what you need to do is try to get airflow to move around that valve. So some of the things I've done in your cylinder head, I've modified the short turn radius and smoothed this so when it comes in on the valve seat, it's more of a gentle curve. On the valve job, stock on this engine was just one angle. This is 45 degrees on both sides. I've done a 2-angle valve job, so it's 45 degrees and a 65 degree blended into the port. And what this does, it helps direct airflow. As it comes through the port, it helps direct airflow to turn around this valve. Another thing that's been done on your cylinder head, I've removed this guide hump slightly. The guide protruded into the port, so I streamlined that and removed some of that. This cylinder head's got really small valves and had really long guides, so I've shortened those. Another thing that has been done to this head, I've back cut the intake valve right here, and I've also done this on the exhaust valve. So as airflow comes in here, it has more room to move around the valve. Another thing, I've blended the chamber. It had some overhanging edges in here. I've smoothed all of that. On the exhaust side, like I said, I've back cut the valves, and I also did another bottom cut on the valve job. This helps direct airflow into the port, and I've also removed that guide, streamlined that guide on this. You'll notice all the inlet port has a rougher texture to it, and I'm trying to keep the fuel in suspension as the fuel molecules come down the port. You don't want them to stick to the port wall, so you use a rougher surface finish on that. The chambers have been kind of slightly polished. Also, the exhaust port is more polished. If you look at the cylinder head, on the inlet side, they're really small, so it's hard to see, but you can see the guide has been streamlined. The chambers are smooth and polished. The valve job is really small and hard to see, but there's multiple angles, and it's all of it's blended in smooth. The exhaust port, same thing. The guide hump has been cut down, and you'll notice the surface finish is smooth, but there's still imperfections in the port, and that's mainly because this has got a larger exhaust port than what this engine really needs, and I didn't want to make it any bigger and hurt port speed and drivability on this engine. You can see the surface has been milled about 5/1000ths on the cylinder head. The cylinder has been decked 8/1000ths, so this gives you a smooth gasket surface. It was bowed before. It took 8/1000ths to clean this up. These cylinders have been bore and honed 10/1000ths over, and to fit the piston. I got new pistons, rings, pins for the engine, and here's the intake manifolds. Those are basically the same. They haven't really been enlarged. I just cleaned up the surface finish on them and did some work in the carburetor. There were some casting marks that have been smoothed and kind of streamlined inside the carburetors. You can see the valves here. These are really small. You can see where the valve seats on the 45 and 30-degree back cut on both the intake and exhaust valves. And now all that's left, I will check the spring pressure and the coil bind. I'm going to shim the valve spring slightly so you've got a little more spring pressure, keep the valve train a little more stable, and just assemble the cylinder head and package it up and send it back to you guys. I hope I haven't forgot anything, and it's been a pleasure to work on this project. I hope you guys do really well, and I was glad to be a part of it. Thanks.